Good morning, students. Now Maxmuller Global Education is going to provide online learning solutions. I am Haribabu. Now I am going to teach you an important lesson in physics, that is refraction of light at plane surfaces. Okay, let us start. Now, let us see what is refraction of light. Refraction of light means when light ray travels from one transparent medium to another transparent medium, it bends at the surface which separates these two media. I will show you through a diagram. Suppose this is the boundary which separates two media. Let us say this is medium 1. This is say medium 2. Now a light ray travels from medium 1 to medium 2. It bends either towards the normal or away from the normal. It bends towards the normal or away from the normal. Now, this is called incident ray, and this is a refracted ray. AB is incident ray. BC is refracted ray, and this is normal N1 N2 drawn at the point of incidence. Now this is medium 1, this is medium 2. Here always the angles are being measured with normal. Now here in this case AB is incident ray and BC is refracted ray, and N1 N2 is the normal drawn at the point of incidence. Now first law of refraction. According to this law, the incident ray, the refracted ray and the normal drawn at the point of incidence lies in the same plane. These three must lie in the same plane. This is the first law of refraction. That means AB, BC and N1, N2 lie in the same plane. Now, suppose this is medium 1, this is medium 2. Now we analyze the refraction of light by getting the concept of refractive index of a medium. Now, refractive index of a medium is the ratio of C by V. That is, C denotes velocity of light in vacuum, and V denotes velocity of light in medium. Okay, so always velocity of light in rarer medium is greater than velocity of light in denser medium. Therefore, always C is greater than V. That means the velocity of light in vacuum is always greater than velocity of light in any other medium. And hence, the refractive index of any medium is greater than 1. This is denoted by mu. Therefore, mu is always greater than 1. Since the velocity of light in vacuum is greater than velocity of light in medium, refractive index is always greater than 1. For vacuum, refractive index mu is equal to 1. Vacuum or air, the value of mu is approximately equal to 1. So now we have concluded 2 points. One is velocity of light is maximum in vacuum when compared to any other medium. It may be water medium, it may be glass medium, it may be any other medium. The velocity of light is less than the velocity of light in vacuum. Now, based upon this refractive index formula, we will see how light refracts when it transfers from rarer to denser or from denser to rarer. Okay. Now we study 2 different cases. In case 1, light travels from rarer medium to denser medium. Let us consider this is rarer medium whose refractive index is mu1. This is denser medium whose refractive index is mu2. When light ray travels from rarer medium to denser medium, it bends towards the normal because the velocity of light is less in denser medium as compared with velocity of light in rarer medium. So this is AB is incident ray, BC is refracted ray, this is the normal drawn and normal drawn at the point of incidence to the surface which separates these 2 media. Now always angles must be measured with normal. This angle is called glancing angle. The angle made by the incident ray with the surface is called glancing angle. I is angle of incidence. R is angle of refraction. I is angle of incidence and R is angle of refraction. In this case, when light travels from rarer to denser medium, R is less than I. In the absence of this medium, the ray would have been traveling in this direction. So therefore, instead of moving in this direction, the ray travels in this direction because of this medium. Therefore, this is called deviation in the ray, refracted ray, denoted by letter delta. So deviation delta is equal to, these 2 are opposite angles, therefore this is equal to I, therefore delta is equal to I minus R. So therefore, you can observe different conditions. When light travels from rarer medium to denser medium, angle of incidence is greater than angle of refraction. Therefore, R is less than I since the ray bends towards the normal. Therefore, the deviation produced in the ray is delta is equal to I minus R. Okay. Now, here already we have discussed the first law of refraction. That is, the incident ray, the refracted ray, and the normal lies in the same plane. And second one is, according to Snell's law, mu1 sin I is equal to mu2 sin R. This law is valid for any number of media. That means mu1 sin I is equal to mu2 sin R. This is very important principle, Snell's law. Mu1 sin I is equal to mu2 sin R. Therefore, light travels from rarer medium to denser medium. Here light ray bends towards the normal. Incident ray, refracted ray, normal lies in the same plane. When it moves from rarer to denser, say for example, air to water, air to glass, water to glass. So rarer to denser, it bends towards the normal. You will get R is less than I, and the deviation produced in the ray is equal to delta is equal to I minus R. And according to Snell's law, we will get mu1 sin I is equal to mu2 sin R. Very important rule. Case 2. When light ray travels from denser medium to rarer medium, what will happen? Suppose this is rarer medium, refractive index is mu1, this is denser medium. Okay. Now, light ray is incidence from denser medium to rarer medium at the point of incidence on the surface which separates these two media. This is incident ray here. This is angle of incidence, always angles being measured with normal. When it travels from denser to rarer, it bends away from the normal. This is a refracted ray, and this is called angle of refraction. This is called angle of refraction. In this case, you can observe that instead of bending towards the normal, it bends away from the normal when it enters from denser medium to rarer medium. Therefore, angle of refraction is greater than angle of incidence. In the previous case, what you have seen is angle of incidence is greater than angle of refraction. Now, in this case, R is greater than I. Now, in the absence of this medium, the ray would have been traveling in this direction. This is I. Therefore, this is called deviation. So, deviation produced in this case is equal to R minus I. In the previous case, the deviation is I minus R. In this case, the deviation is R minus I. So, these two are the important conditions regarding light travels from rarer to denser and from denser to rarer. And also we have discussed the laws of refraction, the incident ray, the refracted ray, and the normal drawn at the point of incidence at the surface which separates these two media must lie in the same plane. Number one. Number two, the product of refractive index and the angle of incidence in that medium should be constant. That means mu into sin theta is constant. Very important. Therefore, we can also write this as mu1 sin I1 sin I is equal to mu2 sin R. Okay. Now, next case is normal incidence. Suppose a light ray incidents normally on the surface. It travels without deviation. Here angle of incidence I is equal to 0 and R is also equal to 0. This is called normal incidence, and deviation is also equal to 0. There is no deviation. So I is equal to 0, R is equal to 0 and deviation is 0. This is called normal incidence. That means here the glancing angle is 90 degrees. Theta, glancing angle. Glancing angle is the angle made by the incident ray with the surface, not with the normal. Not with the normal. It should be measured with the surface. That is called glancing angle. So we have discussed three different situations when light ray travels from rarer to denser. Second case, denser to rarer, and third case is normal incidence. Normal incidence. Problem number 1. If velocity of light in water is 1.5 into 10 power 8 meter per second, find the refractive index of water with respect to air. Now always refractive index of water with respect to air indicates velocity of light in vacuum by velocity of light in medium, water medium. Here we have to find the velocity of light, refractive index of light. So refractive index of medium, water medium. So C is equal to, we know 3 into 10 power 8 meter per second. Velocity of light in vacuum is 3 into 10 power 8 meter per second. Okay. By velocity of light in water medium is 1.5 into 10 power 8. Therefore this gives rise to be 2. Therefore always the refractive index of any medium indicates it should be with respect to vacuum or air. Suppose refractive index of glass is 9 by 8. It indicates refractive index of glass with respect to air. Now, problem number 2. If mu of water is 3 by 2 or mu of water is say 9 by 8 and mu of glass is 3 by 2. Now find mu of glass with respect to water. This is equal to mu of glass by mu of water, both with respect to air. Now mu of glass is 3 by 2 by mu of water is 9 by 8. That comes out to be 24 by 18. That is equal to 12 by 9. If you want to find refractive index of water with respect to glass, refractive index of water by refractive index of glass, mu of water is 9 by 8. Mu of glass is 3 by 2. This is 18 by 24, that is 9 by 12. From these two relations, one can understand mu of glass with respect to water is equal to 1 by mu of water with respect to glass. principle of reversibility. Mu of glass with respect to water is equal to 1 by mu of water with respect to glass. So generally, if velocity of light in any medium is given, if you know velocity of light in vacuum or air, you can find the refractive index of that medium with respect to air. Refractive index of air with respect to refractive index of what? The medium with respect to air can be calculated. Okay. So from this, you can also write mu of 2 with respect to 1 is equal to 1 by mu of 1 with respect to 2. Problem 3. This is a medium whose refractive index mu1 is to be find out, and refractive index of this medium is root 2, or the refractive index of this medium is 1. Air, light travels from rarer to denser, and this is the normal. So this is the incident ray, this is the refracted ray, this angle is 45 degrees. Find the angle of refraction and angle of deviation. First, apply Snell's law. Mu1 sin I is equal to mu2 sin R. Mu1 sin I is equal to mu2 sin R. In the given problem, the value of mu1 is 1 and sin I is sin 45 and mu2 is root 2 into sin R. This is 1 by root 2 is equal to root 2 into sin R. Sin R is equal to 1 by 2. That implies R is 30 degrees. You can observe from this problem, when light ray enters from rarer medium to denser medium, the angle of refraction is less than the angle of incidence. Here the angle of incidence given is 45 degrees, whereas the obtained angle of refraction is 30 degrees only. Now we can find the deviation. In this case, deviation is equal to, I already discussed in the previous class, I minus R, where I is greater than R. Therefore 45 minus 30 degrees, that gives rise 15 degrees is the angle of deviation. So simply apply Snell's law. There is no confusion at all. Mu1 sin I is equal to mu2 sin R. Out of these 4 parameters, 3 will be given. Mu1 I is given, mu1 is given, mu2 is given. You have to find R. In some cases, mu1 I and R will be given. You have to find out the value of mu2. Therefore, out of these 4 parameters, 3 will be given and you will be asked to find out the required parameter. Students, now we discuss an important concept regarding refraction of light at plane surface. That is, one is critical angle and second one is total internal reflection. One is critical angle, second one is total internal reflection. Let us see one by one. Suppose this is denser medium whose refractive index is mu d, mu of denser. And this is rarer medium whose refractive index is mu r. When light ray travels from denser to rarer, suppose this is the angle of incidence, this is the angle of refraction. If you increase the angle of incidence gradually, the angle of refraction also increases. So, as light ray travels from denser to rarer, as angle of incidence increases, angle of refraction also increases. Now, at a particular angle of incidence, the light ray in the rarer medium grazes the surface. That indicates the angle of refraction is 90 degrees. Now I will show this in this diagram. At a particular angle of incidence, I is equal to C. This is critical angle. The angle of refraction is 90 degrees. This is 90 degree. This is rarer, mu of rarer. This is denser, mu of denser. So, this is incident ray and this is refracted ray. So, the angle of incidence in denser medium at which the angle of refraction in the rarer medium is 90 is called critical angle for the given pair of media for the given color of light. Because this critical angle changes pair of media to pair of media. If you take glass and water, if you take water and air, so therefore for a given pair of media for the given color of light, this critical angle is constant. Therefore, we can take this critical angle I is equal to C, at which angle of incidence is 90. Therefore, in order to obtain this critical angle, you need to have two important conditions. Number one, the light ray should travel from denser to rarer, and the angle of incidence is in such a way, angle of refraction is 90 degrees, so that you will get critical angle for the given pair of media for the given color of light. Now apply Snell's law. Mu d, mu of denser into sin C is equal to mu of rarer into sin 90. Sin 90 is 1, therefore very important formula, sin C is equal to mu rarer by mu denser. Usually the students may be mistaken without writing these prefix, because sin C is equal to mu of rarer by mu of denser always. So therefore, you can also write sin C is equal to 1 by mu of denser with respect to rarer. Therefore, mu of denser with respect to rarer is equal to 1 by sin C. Very important and useful relation. Mu of denser with respect to rarer is equal to 1 by sin C. Last point, total internal reflection. Now, if the angle of incidence in the denser medium is equal to critical angle, the angle of refraction is 90 degrees. If you increase the angle which is greater than critical angle, suppose this is angle of incidence, I is greater than critical angle, the light will undergo reflection in the same medium. This phenomena is known as total internal reflection. That means, in order to have total internal reflection, there must be two conditions. Number one, light should travel from denser medium to rarer medium, and angle of incidence must be greater than critical angle for the given pair of media for the given color of light, then light will be totally reflected into the same medium without being refracted. Okay? Thank you, students.